Okay, I have another larger program than this, but it had a feature to do stuff with Commodore 64. And I've been starting to move things out of that project into their own little projects and work them in as a plug-in architecture. So with that, I have this little test harness here that lets me actually interact with the storage medium for a floppy disk for a very old system. This one's specific to the Commodore 64, and the files are normally called D64 when you find them online. So I've been able to find a lot of information about how this is set up. But not only did I want to write the platform or the API to write these D64 files, I wanted to get a visualization of where all the sectors were, the tracks, and how this all worked physically. So you have this, this shell of the floppy disk in the background, and then the actual media that's being written to. And let me load a disk, probably one that is better. Here we go. All right. So you can see there's a lot of scattered files around here. And if I click on one of these, it's going to say the file is called disk and sleeve. And it's a user file. And if you look down here, I have two files. I just renamed one because I can't have duplicate file names. Actually, you could, but it's going to be weird if you do, because I don't think the other one's going to be found easily. But I've made this so that you can't do that. But anyway, you can see the files take up 119 blocks each, and they are about 30 kilobytes. So there are 30. Wait, no, I said 119 blocks of each type. And I made one a user file and one is a sequence. You can see the legend here shows if it's a sequence or user based on the color. And this is scattered. And you may not have heard about this, or you may have about the old days we used to defrag our hard drives. Well, I have a disk defragmenter. There we go. Look at that. It's all pretty. The optimal read area is this track 18. And track 18 is actually a special track which is meant only for your directory and disk information. So here's our disk header is the first sector, or sector 0. And then sector 1 is your actual data for your files. So let's go back to disk 1, the sector 0. And this is a bitmap index of all 255 bytes that sector contains. Let's open that up. And then we have our hex view. The first two digits say where, two hex characters say where you're going to go and what track and what sector. You can see down here we have the name of our disk, Test Lab. This TL is our disk ID. So let's, oh, and I can actually change this. So if I say, I think 4D will change it to TM. There you go, TM. Close. Oh, and my shell changes color based on the disk name and the disk ID. So that's why that changed. Just so I have a random flavor of disk that pops up whenever I look at new stuff, possibly. Okay. So we have the ability to defrag and we also have the ability to fragment. There we go. We just fragmented our disk. I also have this efficiency map, which it doesn't tell me about fragmentation. It tells me how bad it is to, or how good it is to read the next sector based off the link from the prior sector. And some of these are read, which is not good. It's going to take a long time. And there are certain ways, like you can't have one sector read after the next, um, because you should give your head some time to communicate back to the computer or the CPU or whatnot, and then begin to read the next sector. Normally, you would want to wait about 10 sectors before reading again. So that's what this defragmenting disk does, is it figures out um, what is the best path or closest path for where you're at right now versus what's freely available based on the head travel time to move between tracks and sectors. So that's why I have this scoring here. And that's something I was having trouble with with an emulator, is that the disks that I were creating were very, very slow because it's mimicking all of that. Here we go. And I had a very poor reading score of 36. That is extremely low. So if I defragment the disk, there we go, 99%. It's not perfect, but it's way up there. So that's something I've got to look into. Here are the files on that disk. I can go ahead and delete a file. There we go. I deleted this file, 2 kilobytes. The file actually turns red when it's deleted. And it's got this DEL marker. That's not it. So see, it's a DEL type. Now in memory, I know it's a program type, but if I save this and load it again, it's not going to remember that. But I can choose what I'm going to restore my files as and get it back up there to the top, and there it is. I can download the files to my local computer. I can also, let me see where, I can drag and drop files. Oh, here we go, fileid.diz. There, it just added it. Apparently there's 2 of them now, but at least they have different names, so that's good. What else? There's this closed and open and closed, locked and unlocked files. So if you have a locked file, it's protected from being deleted. And if you have an open file, I think other programs can't access it or something. Anyway, this lets me look at the file contents and change those flags and repair them if needed, or just see what's been going on under the hood. Nothing there. So lots of cool stuff. I think that's about it, but it's really a basic program once everything's done. But it's visually, it helps me figure out how things are laid out, and the speed issue is the main thing that really pops out of the efficiency map. That is going to speed up a lot of problems I've been running into.